A new study confirms that Earth's inner core has been rotating more slowly than usual since 2010. This mysterious backtracking could also end up slightly altering the planet's overall rotation, lengthening our days. The heart of our planet has been spinning unusually slowly for the past 14 years, new research confirms. And if this mysterious trend continues, it could potentially lengthen Earth's days, though the effects would likely be imperceptible to us. Earth's inner core is a roughly moon-sized chunk of solid iron and nickel that lies more than 3,000 miles, 4,800 kilometers, below our feet. It is surrounded by the outer core, a superhot layer of molten metals similar to those in the inner core, which is surrounded by a more solid sea of molten rock, known as the mantle and the crust. Although the entire planet rotates, the inner core can spin at a slightly different speed as the mantle and crust due to the viscosity of the outer core. Since scientists started mapping Earth's inner layers with detailed seismic activity records around 40 years ago, the inner core has rotated slightly faster than the mantle and the crust. But in a new study, published June 12 in the journal Nature, researchers found that since 2010, the inner core has been slowing down and is now rotating a bit more slowly than our planet's outer layers. If the inner core's rotation continues to decelerate, its gravitational pull could eventually cause the outer layers of our planet to spin a little more slowly, altering the length of our days, the researchers wrote. However, any potential change would be on the order of thousandths of a second, which would be very hard to notice. As a result, we would likely not have to change our clocks or calendars to adjust for this difference, especially if it were only a temporary change. This is not the first time scientists have suggested that Earth's inner core is slowing down. This phenomenon, known as backtracking, has been debated for around a decade but has been very hard to prove. In the new study, researchers analyzed data from more than 100 repeating earthquakes, seismic events that occur repeatedly at the same location, along a tectonic plate boundary in the South Sandwich Islands in the South Atlantic Ocean between 1991 and 2023. Each earthquake allowed scientists to map the core's position relative to the mantle, and by comparing these measurements, the team was able to see how the inner core's rotation rate changed over time. The new study is the most convincing evidence so far that backtracking has been happening. It is currently unclear why the inner core is backtracking, but it is likely caused by either the churning of the liquid iron outer core that surrounds it or gravitational tugs from the dense regions of the overlying rocky mantle. It is also unclear how frequent backtracking is. It is possible that the inner core's spin is constantly accelerating and decelerating, but these changes likely happen over decades or longer. Therefore, longer data sets are needed to infer anything about long-term trends. The inner core remains one of the most mysterious of Earth's hidden layers. But in recent years, new technologies are allowing researchers to learn more about the inner core, including that it is slightly lopsided, that it is softer than expected, that it potentially wobbles off Earth's axis, and that it has a separate innermost core. The study authors will continue to analyze seismic data to learn more about the heart of our planet and how it changes over time. The dance of the inner core might be even more lively than we know. Let's figure out now what's inside Earth. The center of Earth lies around 4,000 miles under our feet, but what lies beneath the outer crust and the inner core? The center of the Earth is almost 4,000 miles, 6,400 kilometers, beneath our feet. To put that into context, the deepest humans have ever drilled is 7.6 miles, 12.2 kilometers, down, and it took geologists nearly 20 years to get that far. Fortunately, scientists don't have to burrow inside our planet to study it. By measuring seismic waves traveling through Earth, researchers have developed a solid understanding of its basic internal structure. So, what's inside Earth? Planet Earth is broadly composed of a crust, mantle, and core. The crust hosts all known life, but it's merely Earth's outer casing, accounting for only 1% of the planet's total volume. The mantle, or middle layer, makes up 84% of Earth's volume, and the innermost layer, the core, makes up the final 15%. The crust is split into oceanic crust and continental crust. The oceanic crust is 3 to 6 miles, 5 to 10 kilometers, thick and located beneath the oceans, while the continental crust is up to 50 miles, 80 kilometers, thick. The oceanic crust is mostly basalt rock, and it's denser than the continental crust, which is largely granite. So when an oceanic plate collides with a continental plate, the denser oceanic crust travels beneath the continental crust. This process takes a long time, but eventually sends oceanic crust down into the mantle at a rate of 1 to 3 inches, 2 to 8 centimeters, per year. The mantle. The mantle isn't liquid, but it's less rigid than sinking oceanic crust. In geological timescale, it's almost acting like a fluid, although it's solid rock. The mantle is made up of different minerals, but bridgmanite is probably the most abundant. This part of Earth runs to a depth of around 1,800 miles, 2,900 kilometers, and there's an upper mantle and a lower mantle. Earth's internal temperature increases between the boundary of the upper mantle and the bottom of the lower mantle, ranging from around 1,800 to 6,700 degrees Fahrenheit, 1,000 to 3,700 degrees Celsius. A 1,400-mile thick, 2,300 kilometers, sea of molten iron and nickel marks the beginning of Earth's core. This liquid sea, known as the outer core, surrounds a mostly solid iron ball, around 1,520 miles, 2,440 kilometers, wide, called the inner core. The liquid iron outer core swirls around the inner core, giving Earth its magnetic field. Our planet formed around 4.6 billion years ago, and as it cooled, heavier elements such as iron and nickel migrated inward to create the core. The inside of Earth is still cooling, and as it does so, the inner core continues to form. Just like water becoming ice, iron is getting solidified and becoming inner core, so inner core is actually growing, but it's growing more slowly than a human fingernail. The inner core is about as hot as the surface of the sun, but tremendous pressure keeps it mostly solid. Inside the inner core is the innermost core, a 450-mile wide, 725 kilometers, solid metal ball. Friends, I hope that you learned a lot of interesting things today by watching this video. I also hope that you like this video so that this video can be seen by as many curious people as possible who are passionate about space and the origin of our planet. I also hope that you will join to our community and subscribe to the channel. Write in the comments what else you would like to know.